6.3, graphs of tangent, cotangent, secant, and cosecant functions. Our essential question, how do you graph the tangent, cotangent, secant, and cosecant functions? And as long as you're really familiar with sine and cosine, you're going to be pretty good here. So the first thing I want to refresh your memory on is that we can say that tan of theta is, so tan of theta was like, if we were just thinking about the coordinates, we were thinking of the vertical over the horizontal. Well, vertical over horizontal gives us the sine theta over cosine theta. And then cotan is just the inverse of that. Okay, so I'm going to make a table here of values to help us figure out what's going to happen with both of these. If you notice, cosine sometimes becomes 0. So anywhere where cosine is 0, this function is going to be undefined. So we're going to have some vertical asymptotes. And then cotan is going to be the reciprocal of that. So anywhere where sine is equal to 0, this function will be undefined, and that's where our vertical asymptotes will become. All right, so let's think about some values. And I'm actually going to start with negative 90. So I'm going to talk about the degree. I'm going to start with negative 90, and I'm going to go up by 45 degrees. I skipped a couple intervals, so I had to go back and erase. So I skipped 0, I think. 0 and 45. So from negative 45 degrees, we're going to go to 0, then 45, then 90, then 135, then 180, then 225, then 270, then 315, then 360. And I'm going to make a table where I figure out what sine of theta is at that degree, cosine of theta at that degree, and then from that I can figure out tangent, because once again, tangent is just sine over cosine. And that's going to help me graph this, and that's going to help you see where everything's undefined. So again, tangent is going to be undefined anywhere where cosine is equal to 0. You can use your unit circle, you can use your memory, you can use your graphs of sine and cosine. It's totally up to you. But if we go to negative 90, that's really the same thing as 270 degrees. I can see that my sine value is negative 1 and my cosine is 0. If I divide those, I get undefined. So we know that we're going to have a vertical asymptote at negative 90 degrees on this graph. Going to negative 45 degrees is actually the same thing as 315 degrees. And these were the special right triangles, 45, 45, 90. So we know that our legs are both root 2 over 2, but the sine value, because we're in the fourth quadrant, is going to be negative. Dividing those two, I end up with negative 1. Okay, so we also just took care of then 270 degrees, right? This was negative 1, 0, which gave us undefined. And we also just did 315 degrees, which was negative root 2 over 2, root 2 over 2, which is negative 1. At 0 degrees, we have 0 as our sine, 1 as our cosine. And 0 divided by 1 is not undefined. That's just 0. At 45 degrees, it's going to be that root 2, or root 2 over 2, sorry. Root 2 over 2. Divide those, I get 1. At 90 degrees, it's going to be 1 and 0. Well, again, 1 divided by 0, that's undefined. Now at 135, cosine value is going to be negative, but still root 2 over 2 for both. So I get negative 1. At 180, cosine is negative, sine is 0. And again, 0 divided by a negative 1 is 0. I can do that. All right, 225 down here. Both values are root 2 over 2, and they're both negative. So I'm going to end up with a positive 1. And the last one is 360, which is exactly the same as 0 degrees. So we end up with 0, 1, and that's okay. I can divide 0 by 1, and I get 0. All right, so this is going to help us figure out everywhere where this thing's undefined, we're going to have vertical asymptotes. And then I've got some outputs of either +1, -1, or 0. Your tangent graph doesn't have to be that huge because we're really only going up, but I've got plenty of space here, so maybe I'll make it a little bit bigger than it really has to be. Let's see. All right, so I'm going to go by 45 degrees, so I'm going to start with -90. Make sure I don't skip any. Okay, I fit them all on there. Let's see, at -90, I'm undefined. So that means I've got a vertical asymptote there because I've got 0 in the denominator. Where else am I undefined? At 90 degrees. I'm also undefined at 270 degrees. Now at -45, my output was -1. Let's see, I'm going to do -1 here. And I'll go up here for +1. And at 45 degrees, my output was +1. And at 0, my output was 0. So this is basically what every single one of these pieces is going to look like. It's going to approach both of the vertical asymptotes. It's going to kind of look like your cubic function. Something like that. Okay, I'm going to keep going. So at 135, I got an output of -1. At 180, I've got an output of 0. At 225, I've got an output of +1. So I got another branch here. Okay, at 315, I've got an output of -1. At 360, I've got an output of 0. And I bet you can guess if I added 45 to this, so at 405, I'd end up with an output of +1. But I'm just going to go ahead and do this much of this branch. So there's your tangent function, and it keeps going. Let's see. In your book on page 295, your tangent function, you can see it'll just keep going, keep going, keep going. Next, let's graph cotangent. Cotangent is the reciprocal of tangent. So now the graph will be undefined everywhere where sine is 0. So I can see sine being 0 at 0 degrees, at 180, 360, and so on, both in the positive and negative direction. So I will have vertical asymptotes at those values. So I'm not even going to go into the negative x direction. So at 0 degrees, we said, I'm going to have a vertical asymptote. At 180 degrees, and at 360 degrees. Okay, let's find some more values. So let's see. At 45 degrees, well, it's still going to be cosine divided by sine, so that's going to be 1. At 90 degrees, it's going to be cosine divided by sine, so that's going to be 0. And at 135 degrees, it's going to be -√2 divided by √2 over 2, which is going to give you -1. So this graph basically is flipped. It decreases now instead of increasing. So it's still the tangent graph, or it's very similar to it, but your vertical asymptotes happen anywhere where cosine is 0. And then instead of increasing from left to right, it decreases from left to right. Okay, and the same thing's going to happen. So if I look at my next round here, at 225, it's going to be 1. At 270, it was undefined. Or it's going to be 0. And then this is going to give you -1. Again, you can do as many cycles of this as you want. I think we're good enough there. We got the point. But, so again, think to yourself, if you went backwards, you'd be undefined at -180. And your graph would just continue the same way it's been going. Oops, I missed that point, but something like that. Okay, next we'll do the secant graph. Oh, so this is... Let's go ahead and I'm going to put a title on each one of these, kind of off to the side. All right, so secant theta is the reciprocal of cosine. So this is the same thing as 1 over cosine theta. So what we care about here is anywhere where anywhere where theta is 0, cosine theta is going to be undefined. Okay, so where is cosine 0 again? Well, it's at -90, let's see, +90, and +270 degrees. Okay, so those are all places where you're going to, again, have vertical asymptotes. Okay, I updated my graph. So I'm going 45 by 45s up to 360, and then by 45s down to -270. So as we said, at 90 degrees, this thing's going to be undefined because that's where cosine equals 0. At -90 degrees as well. At +270, which is the same as -90. And then at -270, which is the same as +90. Now, the best way to graph this is to graph the cosine function first. Okay, so cosine function goes like this, up to 180, back to my midline, up back to my highest point. And then I'll go the other direction, so midline, lowest point, midline. So that's part of it. You can do this with a dotted line. I'm going to go ahead and use a solid, and then I'll come back with a colored pencil. To highlight my new graph that I'm learning. So the thing about secant is, again, it's 1 over cosine. So, at 0 degrees, cosine is 1. So 1 divided by 1 is going to still be 1. So you have an output that's exactly the same. At negative 45, cosine is root 2 over 2. So 1 divided by root 2 over 2 is going to be something greater than 1. Okay, so we're increasing as we go to the left. And the same thing, 45 degrees is also root 2 over 2. So 1 divided by root 2 over 2. And so on. It's going to be bigger, something bigger than 1. So as we are headed towards these asymptotes, we're increasing. Oh, that should just look like a really nice parabola. Okay, so I'm going to use another color to show that piece. And the same thing happens like at 180. So at all of these maxes and mins of the cosine graph, you're going to have these parabolas that are approaching the asymptotes. 180 and negative 180, same thing, right? So you're going to have the exact same type of parabola right there. And then I'll just do part of the graph. So 360 is another high point. And we'll just do half of a parabola. So the green portion is the graph of y equals secant theta. The part that I have just penciled out here, I'm going to go ahead and call that y equals cosine theta so that I can distinguish. Okay, so really the graph is just the green parts. But me personally, I like to have the graph of y equals cosine and then go off of that. So once again, remember that cosecant is the same as 1 over sine theta. So like at 90 degrees, for example, sine theta is 1. So 1 divided by 1 is 1, so your output's the same. Okay, and at 45 degrees, remember it's root 2 over 2. Okay, and same at like 135 degrees. So that means that this thing's growing, right? So it's a parabola that's basically opening up and approaching the asymptotes. Whereas at 270, sine is negative 1. So divide 1 by negative 1, you get a negative 1 output. And then like at 225 and at 315, the outputs are negative root 2 over 2. So you're going to end up with a negative output. Again, we're just approaching these asymptotes. Okay, once again, at 90 degrees, at negative 90, well, that's the same as 270. So basically, that looks exactly like this piece. Just pretend like it looks perfect. Sorry, I totally messed that up. And then at negative 270, well, that's the same as 90 degrees. So you're going to have a piece that looks just like at 90 degrees. All right, so our graph, again, I just use the sine function to help me get those highs and lows. It's important, though, you have to know where those vertical asymptotes are, and again, they happen wherever sine is equal to 0. So if you have a really good working knowledge of your unit circle, like that's what pops into my head while I'm doing this. I have visualized the unit circle. Okay, so my green is going to be y equals cosecant theta. And then this graph that I originally graphed, that was my sine theta. All right, so you just learned 4 new graphs. And we can add these to our parent graphs together in class. But definitely study these and realize that the way that we came up with them was basically thinking about sine and cosine and how they relate to each other as tangent, as cotangent, as secant, and as cosecant. And let me just remind you that page 295 has all 4 graphs for you to study, and you can also use your graphing calculator to get a better idea of these.